Okay, so we're going to start talking about inductive reasoning and conjectures to start off Chapter 2. So a conjecture is essentially just a conclusion. Nothing more. It's an educated guess based on what you know, and we're going to try making conjectures based on the following info. So let's look at this pattern. We got 1, 4, 9, 16, 25, 36, and 49. Our conjecture is what comes next. Well, if you look at this, this is 1 squared. This is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. So this is going to be 8 squared, which is 64. We could keep going, 9 squared, 81, and then 100, which is 10 squared. When we look down here at this one, 1, negative 2, positive 3, negative 4, positive 5, negative 6, positive 7. What's happening each time is we're multiplying it by a negative, and we're adding 1. So 7 becomes negative 8, negative 8 becomes positive 9, positive 9 becomes negative 10. So conjecture is, based on the information you have, what's next? So let's make a conjecture based on B is the midpoint of AC. So I'm actually going to draw this. Let me draw a straight line. We have AC, and we have the info that B is the midpoint. Okay, now I already marked it, and that's actually going to be our first conjecture, is that AB is congruent to BC. Because it's a midpoint, our conjecture is that they're congruent. Another conjecture we can make is kind of a play off of that, and it's that AB is 1/2 of AC, where each one of these is 1/2 because they're equal. And a third conjecture, it's not because it's a midpoint, it's just because it's a point in between the two, is we can say that if I add those up, I get the entire segment. That doesn't have to be midpoint. Instead of midpoint, this one could be just saying between. Our second one, BC, let's put an arrow above this because it's a ray, bisects EBF. So we have a ray bisecting an angle. So let's draw our angle. And let's label it. Let me get back to pen. E, B, F. And we have a ray bisecting it. Now remember, bisecting means splits perfectly in half, so I'm going to write these as angle 1 and angle 2. We know that angle 1 is congruent to angle 2. Another conjecture we can make is similar to what we did on this previous slide. Is we could say that angle 1 is 1/2, and when we're talking about angle measures, we want to write the measure of angle 1 is 1/2 the measure of angle EBF. And then we could also say angle 1 plus angle 2 equals the other angle, but we don't need to right now. And let's make a third conjecture. We know that AB is perpendicular to CD. Okay, so AB, let's draw 2 lines. Let's do this. AB, CD, and I held shift so I know that they're perpendicular. Oops. A and B and C and D. Now, we know the perpendicular. Perpendicular tells us 90 degrees. I'm going to call this point here angle E, or point E, so we can say as our conjecture angle AED is equal to 90 degrees. You could pick any of the 4 angles because if that's 90, all 4 of them are 90. Oops, too far. Let's make a conjecture about this diagram. To make it easier, I'm going to number them 1, 2, 3, and 4. Now, something to remember is that vertical angles are the angles that are across from each other. They're congruent. Angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. We also know that since this forms a straight line, we have 4 sets of supplementary angles. Angles 1 and 2, so I'm just going to use one of these as an example. You can use 2 and 3, or 3 and 4, or 1 and 4. Any of those will work. Now, inductive reasoning is the process of making a conjecture. You use what you know to come up with a plausible generalization. So you're making a conclusion. The bad thing about that is that sometimes they're false. Conjectures can be false, and we prove that they're false by making one counterexample. If you can draw something that disproves your conjecture, you've created a counterexample. So let's take a look at this one. We're going to do one that's not related to math, one that is. So Joe, Bob, Michael, and Peter are all wearing red shirts to geometry. So we can conclude all boys in geometry wear red shirts. Is that true? The answer is going to be no. And why not? What if after Joe, Bob, Michael, and Peter, Billy comes into class and Billy is wearing blue? Since Billy's wearing blue, he is the counterexample to all boys wearing red. Since Billy's wearing blue, not all boys wear red, so that's actually a false statement. Now let's look at that in geometry terms. M is between A and B, so let's go ahead and draw that. We have segment AB, and then we have point M. I just drew it in between. And what we're going to do is we're going to look at M being the midpoint as my conclusion. If I were to move M to right here so that I was able to say this, that would be true. M is the midpoint of AB. But I want to draw a counterexample, so I'm actually going to go back to my first picture. When I look over here, and I'm going to label this, anytime you label it, you solidify your counterexample. Let's call this 9. Let's call this a length of 3. Since those two aren't the same, M is not a midpoint, which means our conclusion is false, and we've provided a counterexample.